and welcome to Chapter 8. Today we are covering EIGRP Advanced Configurations and Troubleshooting. So we are going to configure another EIGRP topology, and we're going to go into a little bit details about more configurations, fine-tuning for example, manual summarizations. We're going to be able to set a default route and how to propagate that default route out. We're going to set up some authentications, change the hello interval and the whole time interval like we did with the with OSPF. All right, so by the end of this chapter, you should be an expert in EIGRP. All right, and maybe we'll take a look at some troubleshooting configuration towards the end. What commands do you really need to do? All right, so here's the list of all the objectives that we are intend to achieve by the end of this lecture. All right, so assuming that you have the following topology for IP version 4, you have routers 1, 2, and 3, and you have the ISP connected to the outside world, and you got your old configuration ready to go. All right. So what you want to do is you want to be able to summarize what is, route summarization. I think we discussed it previously last semester, but route summarization allows you to have less route in the routing table. And if you have less routes in the routing table, that means the router will have less routes to look up. So the lookup process is quicker, and therefore packets move quicker, right? That's the whole idea. If you don't summarize all the routes in the routing table, then you have a list of all the routes. Everything is connected. So sometimes it's a good idea to summarize. Other times it might be an issue because you may have packet looping or may cause a problem, which we'll discuss in a few minutes. All right. Now, all the automatic summarization is disabled with the newer operating system 15.0. Anything with 2.3 and prior to that, the automatic summarization was enabled. So if you wanted to disable it, you would have to type um, no auto summary, right? So with 15.0, you don't even have to do that. Okay. If you wanted to summarize a route, you just go to router EIGRP and you type in that autonomous system number 10, 20, or whatever, and just say auto summary, and bingo, it's all done. If you do not want any auto summary, just type no auto summary at the end instead of auto summary. Okay, I think that's pretty understandable. All right, if you want to verify if you have auto summarization, you just type show IP protocols and it will show right here. It will tell you if auto summarization is enabled or not. So if you're having trouble and you're troubleshooting and you want to find out if the router has been summarized or not summarized, just type show IP protocols and it will display it right in here. All right, if you also show IP EIGRP topology on all the links, you're looking at the topology table, it's going to tell you that this network 172.16.0.0/16 has two child routes, right? And that means these two are connected, all right? So you can also tell that you have only two routes in the routing table, not multiple, to that destination. And you can also do that by showing, show IP route, the routing table. And you see the output serial 0001, and this is, oops, sorry about that. And this is also 01. You can tell that this has not been auto summarized because there's two outputs at serial 01. Auto summarization means you're trying to find the something common in all the outputs, in all the destinations that are going out of the same serial port. So you can summarize them all together into one route, leaving that exit interface. When we do the actual configuration, you'll see what I'm talking about. We're going to do that tonight. All right. Now, here's an example where you may have a problem with auto summarization. So let's say Router 1 sends a summary route to R2 telling him, listen, I'm sending you 172.16.00 with /16. I have a summary route. So anybody that matches 172.16, send them to me, right? So he puts that in his routing table. But he has a default route that is set to R1, the quad zeros. So for example, what happens if somebody came in and sent to him 172.16.4? So when he gets it, he doesn't have 172.16.4. So by default, he sends it to him. But when he receives it, he doesn't have 16.4 either, right? So he says, send it back to R2. But then he goes back. Again, the default route sends it back to him. So therefore, the packet keeps looping back and forth. All right, so sometimes you have to disable, you don't want the auto summarization. You want to display everything that you have, and he wants everything that he has. So this way, the packet don't loop. Or you can use what's called the null zero. The null zero, when he puts in a summary route, he puts the summary route and he puts null zero at the end. So when he sends a packet 172.16.4 to the routing, the first thing he's going to do is he's going to check this. If it doesn't match, if it doesn't match any of these entries in, don't send it back, drop the packet. That's what null zero means. So this way you don't have to send it back. Okay? So if it doesn't match the 172, the zero, you're going to drop the packet. So null zero solves the problem. Manual summarization can be configured on the router, so and we'll do that tonight. We'll do it when we do our packet tracer. With classless protocol, it includes the subnet mask, or now manual summarization can include supernet routes as well. What is a supernet route? A supernet route is a route that is, if let's say it was class B, it's supposed to be /16, you have a class B with /12. It went into the network address. It's called a supernet, really. Supernet is an aggregation of multiple major classful network. Classful is being class A, B, and C. Here's a typical manual summarization. Let's say you have these three network addresses on one router, and they are all exiting the same serial 000 interface. So why can't we summarize all three of them into one route? So what we do is we look and we see the 192 is the same on all three of them, so that's good. 168 is the same on all three of them, that's good. But the third byte, there's something different. And everything is the same on the third byte except all the way up to the first 6 bits are good. Then the last 2 bits, they're not common. So what you do is you write down 192, 168, and when you write all these zeros and everything after that, it becomes zero. So 192, 168.0.0, but the slash is what? 16 bits are common, but wait, 8, 16, and another 6, which is /22. So you write /22 right here as a summary. So you go to the interface 00 and you say IP summary address for EIGRP with the autonomous system is 192.168.0.0 /22 instead of whatever this slash is. It probably was /24. Okay, we're going to do this again. You'll see what I'm talking about when we do it on the packet tracer. All right, you can also do pretty much the same thing with IPv6. All you have to do is use the subnets, the fourth hex stat. So if you eliminate that, you can say the first 48 bits are the same out of the serial port. Just give me the network address regardless of what the subnet is. So just as simple as the same, it's exactly the same command that you would use, but of course with an IPv6 address instead. Okay, now, and we will discuss the redistribute static command, but let's say R2 is connected, wants to go out. The default route means that if the packet doesn't match any routes in the routing table, we're going to send it out to the internet. Well, not necessarily to the internet, to another network going out of the serial 010. All right, now you want to tell all the routers that are running EIGRP to set the default route to you in case if they don't have a default route. So what you do is you go to the router EIGRP1 and you type in redistribute static. Now what that does is it will tell all the neighboring routers that are running EIGRP to insert a default route to you, in this case to R2. Again, we will do this also with our packet tracer and you'll see what we're talking about. All right. So if you want to verify the default route, just type show IP route and you'll see the D for running, EIGRP with the star and EX, meaning I got my default route from a neighbor running EIGRP, not by typing the quad zeros. Okay. You can do pretty much the same thing with IPv6. Just go to the serial port. Here's a default route out of serial 0, 1, 0. Then you go to the router EIGRP2 and say redistribute static, pretty much. Sometimes you have to type in the maximum transmission rate, the unit MTU, and all of that stuff. But in our cases with IPv4, we really don't do that. After you type the word redistribute static, so you can type in metric 64. That's the maximum. That is the maximum transmission MTU, the maximum packet size that has to be transmitted, and 2000, 155, and 1005. Between 64 and 1500 bytes that you can send, no more, no less. All right, now when it comes to bandwidth utilization, by default, EIGRP only uses 50% of the interface bandwidth. You can change that. So you can change that to either less or more. Now, the reason they make sure they only use 50% of the bandwidth is to prevent the EIGRP process from overutilizing the link. And if you just go and do it at 100%, they're not going to be able to handle a lot of packets in and out. So you want just to use half of the bandwidth. So if you're running at 100 megabits per second, usually when you're running EIGRP, you'll only be running at 50 meg. Sometimes you can lower or increase that bandwidth if you want. You can increase it just to have it convert a little bit quicker, or decrease it if you want to make sure that the interface can handle a little bit more data when it comes for more packets that are coming in. All right, so pretty much the same thing with IPv6. You just type in the command IPv6 bandwidth percent with the EIGRP. Hold down timers and the dead time intervals, pretty much the same thing for the same ones that we use with OSPF. The hello interval is the one. How often do you want to go and say hello to your neighbors? You can decrease this number if you want the convergence to be very quick. Increase it if you really don't care because it creates bandwidth. It eats up a lot of bandwidth. You can increase these numbers. We'll do some of these too as well. All right. Load balancing. If you have multiple routes to the destination, you can tell EIGRP to use these multiple routes to get to the destination, so you can offset, or alleviate or mitigate against bottlenecking. So if you have 2 links or 3 links or 4 links, you can tell EIGRP to use all 4 or 6 links at the same time. Okay. So by typing maximum paths, and you put in a value of 1 or 2 or 3. Okay. So if you put 1, that means you're really disabling it. If you put 2 or 3, that means wow, so EIGRP can have up to 32 equal costs. If all the links to the destination are equal, you can use all of them. So that's great. All right, so here you can tell right here that you have multiple routes to the destination. They all have the same bandwidth plus delay. Remember that? That's the feasible distance. And you got 2 interfaces. So data going to this destination will go throughout of serial 001 and 000 as well. So you got 2 interfaces. That's for load balancing. You can tell by typing show IPv6 route. right? Authentication. Now, we will also do this. We'll try to do that also with our packet tracer. Now, you want all the routers that are going between, they're going to share updates to each other. You want them to pass passwords to each other before they send updates. We did that with OSPF, and we want to do that also with EIGRP. So the first thing you do is you create a keychain, you give it a name, and you write in the key ID number, which is usually number one, and then this is really the password, the key string. So once the keychain is created, the name, the ID for it, and what the password in that chain is, then you go to the interface. Let's say serial 000, and you say that's facing another router that's going to send the updates, and you say IP authentication mode EIGRP, and you use, that's EIGRP 10 or 1. And you say, I want to use the message digest number 5 in encrypting this keychain, which is this text. And then you go IP authentication keychain EIGRP number 5 or number 6 or 10. And the name of the chain, which is this. We'll do that. You'll see what we're talking about. Here's an example, right? They called it EIGRP key. The ID was 1 and the password was Cisco in that chain. Then you went to the interface serial 000. You said, I want to use a message digest number 5 in encrypting this, which is really the strongest, encrypting this keychain, key string, Cisco 123. And then you say, all right, and this is how you do it. You go say IP authentication keychain, EIGRP1, EIGRP key, which is the name of the chain. And that's it. You do the same thing on all the interfaces, and you got to do it on all the routers. All right. So you could do pretty much the same thing for IPv6. So you type keychain EIGRP for, just give it a different name. The setup is exactly the same, no difference. Right? How do you verify authentication? Just type show IP EIGRP neighbors. Make sure that you see them, or show IP route will also do it. Right? All right, now we can get into, let's go and do the actual, before we get into troubleshooting, let's go and do our configuration and see what we're doing. So let's go and open up Packet Tracer. And what we want to do is we want to put in 3 routers. Let's put in a 2811 router here, and another 2811, and another 2811 down here maybe. Let's call this router R1. Let's call this router R2. And let's call this one, this is going to be the service provider. Well, let's call it ISP router, because that's where we're going to be getting on the internet. All right, we need to put serial ports in there. So let's go in and on the back of the router, turn off the router and install a WIC2T. Turn the router back on and go to router 2. And install a wide area interface card 2, same spot in here. And oops, I got to turn the router back on. And let's go to the ISP router. All right, and put a WIC2T in there as well and turn the router back on. All right, let's make sure that R2 is the, well, let's do this. Let's do in the link. Well, let's not. Put in a serial DCE. Let's make R1 is the DCE from serial 000 to serial 000, and put another DCE from R2 serial 01 to the ISP serial 000. All right, I'm going to put in a genetic PC on R1 and maybe just a genetic PC on the ISP. Okay, then I'm going to connect PC0, which is on R1, to the fast Ethernet 00, and PC1, which is on the ISP, to the fast Ethernet 000. Okay, so here's what I'm going to do. I'm going to make this network so we don't have to get into anything that is not, well, let me see. Let's say I want network A to be 150.80.160.80, not dot 160, dot 80.10.160 slash 27. All right, let's make this link 172.16.100.0 slash 30. Let's make this one 172.16.100.4 slash 30. All right, and let's make the ISP network 10.20.30.128 slash 26. Okay. All right. So this is going to be going on to the internet. Let's go and let's say this PC. Now, if I wanted to find out what's the last IP address here, by the way, this is a CCNA question. They're giving you an IP address like this, 150.80.10.160 slash 27 and say, what's the last valid address? How do you know? Well, slash 27 ends with 224, right? And 250, find out what the block size is. 256 minus 224 is what? 256 minus 224 is 32. And 160 plus 32 is 192, right? That will be the last address here, 192. And the last address, like we always did in class, is 192 minus 2, which would be 190. So the default gateway will get the dot 190. All right, so let's go in and give it the first address, which is 150.80.10.161. The subnet mask should be 255.254, and the default gateway is 150.80.10, and we said it's 190, right? So let's go right here to PC1, see what we can do there. Just remember, this is 190, right? Now, if we go to PC1, first address is what? 10.20.30.129, right? And it's a slash 26, so it's 255, 192. What's the last address? So remember, slash 26 ends with 192. So what's the block size? 256 minus 192 is 64. And 128 plus, let me just change this dot, there's an extra dot in there. 128 plus the 64 is also 192. And 192 minus 2 is also 190. So this also gets dot 190, but with a slash 26 instead, right? So it's 1020.30.190, right? That's the last address in the network. All right, now let's configure just the interfaces, the basic interfaces. And let's go to the CLI, say no. And en config t. And let's say a host name R1, no IP domain lookup, right? Let me go to the interface fast Ethernet 00, and we set that the IP ad is 150.80.10.190 with 255.255.224, and say no shut on it. Okay. All right. Now, this one right here, the serial 000, we said it's a DCE, right? We got to put a clock rate on it, and it's going to get .1. So let's go to the interface serial 000 and say IP add 172.16.100.1 with 255.255.252 because it's a slash 32. Give it a clock rate of 64,000 and a no shutter, right? We're all good on R1. Now we can go to R2. R2 has this serial 000 interface. Let's do the interfaces. And we go to CLI, we say no, and we say en config t, and then no IP domain lookup, and we say a host name of R2. We go to the interface of serial 000. If this was .1, this is going to be .2, right? And I say IP add 172.16.100.2. 172. And with a subnet mask of 255, 255, 255.252. Now, it's not a DCE, so all it needs is a no shot. And then I go to interface serial 001. And that's a DCE, right? Your serial 001, right? I'm going right here, serial 001. That's right. And it's a DCE. I saw that little clock pop up. I give it the IP add. Let me just move this over so I can read what the address is. The IP add is going to be 172.16.100.5. We'll give it the first address, and this one will get the .6, right? 255, 255, 255.252, right? And it needs a clock rate of 64,000. And we'll say a no shot. All right. What else do I want to do? I want to add 3 loopback addresses up here. Loopback addresses is a virtual interface that's inside the router. So I'm going to say here, I'm going to write them down first. So this way we'll know. I'm going to say L0 is going to be 192.168.10.1/24. I'm going to create also L1 loopback 1. This is loopback LO0. This is loopback is going to be 192.168.11.1/24. And I'm going to do LO2, and that's going to be 192.168.12.1/24. Right? So I'll have 3 different networks in here, like 3 different interfaces. So let's go and do that, see how we can configure a virtual interface. A virtual interface, you don't even have to type no shut on it. Once you do it, because it's inside the router, it becomes active, and you use it for really testing purposes more than anything else. So you type INT, go inside the router. We are on, no, this is no good. This is router R1. No, see, then I named it R1. How did I do that? Oh my God. Host name R2. Let me just make sure. This is R1. Good. And this is now R2. Okay, good. I just want to make sure that the host name is correct because I don't want to get confused. All right. Let me go to interface LO0 and just hit enter. See, it comes up immediately because it's a virtual interface. And just give it an IP address. 192.168.10.1 with 255, 255, 255.0. Let's make it a slash. Let's make interface LO, the letter O1. Enter. And let's give it the IP add 192.168.11.1. 255, 255, 255.0. And let's create LO2, loopback number 2, and say that the IP add is 192.168.12.1 with 255, 255, 255.0. All right, so now I have the 3 loopback addresses as if I have 3 interfaces right here, 3 networks attached. Okay, I want to do that purposely so when we do the what do you call it, the summary route, you'll see how all of these 3 are summarized when they are being sent out. All right, we're done with router 2. Let's go to the ISP router and configure that. So I'll just say no right here and say en config t and say no IP domain lookup, and then say a host name is the ISP. Then I'm going to go to interface fast Ethernet 0/0 and say that the IP ad is 10.20.30, and we set that the last IP address is 190, right? 190 with a subnet mask of 255, 255, 255, 192 because it's /26. And let's activate it. No shot. Now, let's go to the serial interface. It should get .6, right? Let's go to the interface of serial 000 and say that the IP ad is 192.168.10. Uh-oh. 172.16.100.6. 255, 255, 255.252. And all it needs is a no shutter. All right, now we're ready to do EIGRP. So let's run EIGRP on these three routers and just send out, just like we did last from chapter 7, right? So I'll go to R1 and I'll put it right up here. This way you can see what we're talking about. All right, you should be at the router mode, at the config mode, and to enable EIGRP, you say router EIGRP. Let's use the autonomous system number 10 this time, right? Now, number 10 has to be the same on all of them to be able to communicate. All right, then we're going to say network. We want to advertise this subnet. So you'll write 150.80.10.160. Now we need the wildcard for /27. If you guys don't remember how to do the wildcard, just ignore this for a second. So the wild card is equal to 255, 255, 255, 255. 4 255s, and you subtract /27. And /27 is 255, 255, 255.224. And what's our result? 255 minus 255 is 0. And then dot. 255 minus 255, another 0. 255 minus 255, another 0. 255 minus 224 is 31, right? So this is our wildcard. That's how you get the wildcard. All right, let's go back to our configuration and say 0.0.0.31. .31, right? Okay, let's advertise the link. You say network and 172.16.100.0 with a wildcard of a /30, and you'll end up with 3 zeros and a 3, right? Now, let's make sure that no updates go into the LAN interface. So you type PAS for passive, hit the tab key, and say FA0/0. Now, should we disable, say no auto summary? Now, if you don't know what version of this, how do you know what operating system version is doing? So if it's 15 or 12, so you type do show VER, Victor, Easy, Robert, or version, write the word version. And I can tell right here that this is 2.4. So we have to do no auto summary, right? So I go back, hit space, and say no auto summary because summarization is done automatically under 2.0 and later. Okay? All right, let's leave it at that. Let's go to R2 now. Go to R2, and at the config mode, you're going to say router, EIGRP. Remember the autonomous system was 10, so it has to be the same here. And you're going to say network. Well, first of all, let's get rid of the two links. The 172.16.100.0 with 3 zeros and a 3. Okay. And we have the other link, the 172.16.100, the .4, right? Okay, then we got the 3 networks of the loopbacks, right? So it's going to be here 192.168.10.0 slash 24 has .255 at the end, right, for the wildcard. And then we have the .11 and we have the .12, right, for those. So now we got all of them. Okay, no auto sum, no auto dash sum. And then you type passive interface on the loopback addresses, right? Passive interface on L, the letter O, and the number 0. The letter, and then on the 1, assuming that they are LAN, they're virtual NICs. Okay, let's go to the ISP router and enable the EIGRP as well. Okay, so let's go into the ISP router, type exit, make sure you're at the config mode, and you're going to say router EIGRP number 10. And you're going to say network, and the network is 10.20.30.128, right? And the wildcard for /26, it ends with 192. 255 minus 192 is what? 63, right? And you need this link, right? Network 172.16.100.4 with a wildcard of 0003. Okay. No auto sum. Have to put a dash in there. And the passive interface on the fast Ethernet 0/0. We're pretty much done. So let's verify. Do Control Z on the ISP router and do show IP route. All right. So here are, check this out. We have 1D, 1D, 1D. Those 3Ds are the loopback addresses that's coming from here. So I see them now. And they're all coming out of the serial 000. You see, because we did not summarize the route, I have 3 of them listed. That takes a long time to go through this, right? And I have the 150, 80, 10, 160, right? That's this guy right here. Let's look at R2. And let's do Control Z and do show IP route. Pretty much the same thing. Well, you got the directly connected loopback addresses, 0, 1, 2, and 3. And you got the Ds coming from here and from the other side, right? The 10, this network, and on the other side is the 150/80 network with the /27 out of serial 000. All right, let's go to R1, do Control Z, and type show IP route. And you pretty much see the same thing, right? You see the 3 loopback addresses. Now you could type show IP protocols, and that will tell you that you have learned network 150, 180. You're routing for these network and this network. That's what you're sending out. right? And you're running EIGRP number 10. That's what you're advertising. So if you want to know what you're advertising, you could do that by typing IP, protocols, and you know you're advertising this slash 27 network, your network, and the link network. And you said we want the fast Ethernet to be passive, which means no EIGRP updates are going to go through in here, right? Okay, now, first thing we are going to do is we should do, let's do some summarization. Let's summarize all of these three as one and then tell R1, listen, I'm going to give you one summary route. So instead of having these three routes in the routing table, R1 will only have one when R2 sends it to them, right? Coming out of serials 000. So we want to find something common between 192.168.10, 11, and 12. All right, so here's how we're going to do the summarization. For R2, R2 is going to send it out of here and out of here too. So these, R1 and the ISP have a smaller routing table. So I'll go right here. I have done it already just up here. I wrote out 192.168.10, 11, and 12. I want to find something in common in these three routes. Well, what's common is the 192, the 168, and well, there's something not common on the third byte, right? So what I do is I break it down in binary, the 10, the 11, and the 12. Here's the 10 in binary, 4 zeros, 1010, that's a 10. 4 zeros, 1011, that's the 11. 4 zeros, 1100, that's the 12. So what's common? The first 8 bits, I wrote it down. The 168 is also good. And the first 5 bits are common in all three of them. So I wrote them down. Anything after that, if they are not common, you make it all zeros. All right? So if I make this all zeros, what do I read? 192, 168, and this byte is 8, right? Dot the last byte, which is 0. What's common? 192.168.8/21. The first 21 bits are the same. So these three guys share the first 21 bits, which is 192.168.10.8. So this is the summary route that R2 will send to R1 and to the ISP. So how do we do that? You go back to R2, and since we already summarized the route, you're going to go config T, and then you're going to go to the interface. First of all, we're going to send it out of here. First of all, you got to be running EIGRP number 10, right? And you could either send you already send these or didn't send these. It doesn't matter. So you're going to go to the serial interface, which is this one right here, the serial 000, and you're going to say IPSUM and hit the tab key, IP summary address for EIGRP number 10. I have the summary 192.168.10, not .10, I'm sorry, .8.0 with uh, a subnot mask of 255, 255, 252.0, right? That's a slash 20. What's a slash 21? Not 252. That's wrong. It's 248, right? Hit enter. So now it's send it. We'll check it out in a minute to make sure it got rid of all of those three routes. Let me go to this serial interface and send the summary out too. So let me go to the interface serial 001 and say, oops, sorry. Let me just type it correctly. Interface serial 001 and say IP summary route address 192.168.8.0 with slash 21. Oh, we forgot to write IP summary route for who? For EIGRP number 10. That's the summary route. And let me see, IP summary route for, I wrote EIGRP, I wrote S, oh my God. It's an EIGRP. There you go. And there you go. Now, if you go to R1 and hit enter and type show IP route, you see there's your summary route out of serial 000 192.168.8.0/21. That's been summarized. If you go to the ISP, and you should also get the same one. There you go. One route in the routing table. You don't see all three of them, right? You guys, you can still ping each other, by the way. It will work still fine. All right, so that's manual summarization. Now, let's go to R2 for a second and type Control Z and type show IP route. Now, as you can see, if a packet comes in and it doesn't match any of these, what's going to happen to that packet? It's going to go in the garbage. By the way, here's that null zero thing that we talked about when we were doing the slides. But leaving that for now, if a packet comes in and it doesn't match anything, what's going to happen to the packet? It's going to get dropped. Why? Because the gateway of last resort is not set. So what I want to do is I want to go to this router and tell the router, do a default route to the ISP, right? So I'm going to do, if you remember that from last semester, config T. The default route is IP route quad zeros space quad 0.0.0.0.0 space. You can either choose your serial exit interface, serial 001, or the next hop address. So let me use the exit interface. It's 001. S0/0/1. So how do you confirm that there's a default route? You just go and type show IP route. And there it is. It shows up all, it shows, oh, you're going to hit the space bar. You see the S with the star, right? That means I typed it statically and it shows up here. So any packet that doesn't match will be sent out of serial 001, and that means it'll go to the ISP, correct? And therefore, and there it is, it shows right here. But this guy doesn't have a default route. So we don't want to do another ISP. Here's what we're going to do. We're going to tell the router, listen, I want you, we're going to tell R2. R2 is going to send that for this one and even the ISP, unfortunately, because he's running EIGRP. We're going to tell them, listen, if anybody does not match your packet, if a packet comes in into your router, R1 or the ISP, and it doesn't match the routing table, send your default route to me, and I'll take care of it. So how do you do that? How does R2 propagate this default route that it did to R1 and R2? So what you do is you go to R2, go to config C, and go to router EIGRP number 10 and say redistribute, or type the word red and then static. And what we just did is we just distribute this routing, this default route that I did to R1 and R2. If you go to R1, now they should have a default route in the routing table. So if you go to R1, hit the upper key, show IP route, and you see it, look at the bottom right here, a D with the EX. That means I have learned this default route from an EIGRP from router 2. That's what the EX means. If you go to the ISP, he pretty much has the same thing because he's also running EIGRP. But what happens when you send it to him? If ultimately he'll send it back to him, we're going to create a loop here. That's not good, right? Because if a packet doesn't match here, he'll send it, actually he'll send it to this interface, and if it doesn't match here, he said to send it back to him, and we just created a loop. You see that? That's not intentional though. Well, it's just an example. You should not do this. You should not, actually we should ignore, we should take out this default route in here. But that was just an example on how you can actually create a loop. All right. Anyway, we should not be running EIGRP between these two guys. There should be their own ISP routing protocol. It should be just privately. Okay, so let's go in. Let's see if we can change. Let's see if Packet Tracer can actually change the bandwidth utilization. Let me go to R2 and go to the serial 001. Go to interface serial 001. Oops, am I doing anything? No, let's not typing. Go to interface serial 001, and I'm going to say IP bandwidth. Okay, I don't think it. And is there a bandwidth? Nope, we cannot do bandwidth, unfortunately. But you know what we can do? We can change the hello interval. So let's change the hello interval and the hold time. Can we do the hold time? Hello interval, and that's it. No hold time. All right, so let's do, since we are right here on the serial 001, let's do the hello interval, and let's make it 50. Hello interval. Oh, we need to say for EIGRP number 10, it should be 50. Okay. Let me see if I can. I don't think they have the hold. Nope, they don't have it. All right, so we got to make sure that all of them has the same hello interval. So we'll go to the ISP. See, now it expired. We got to go brought this interface down. So we got to go and make sure we change it. Go to config T. Go to the interface serial 000 and say IP hello interval for EIGRP number 10. I want it to be 50. Now for EIGRP, I want it to be 50. So that should fix the problem. Now everything else is good and running. So now I changed the hello interval between these two. All right. And now we're all good, right? Okay, now let's do authentication. Hold time expired. We changed it to 50 from 60. Ah, that's okay. On the serial 000. So there you go. A new adjacency has been done, so we're all good. All right, now let's do authentication between these two guys. All right, when they pass updates to each other because we are inside the internal router. So I'm going to go to R1 first, and I'm going to create the key. So make sure you go to the config mode. All right, and I'm going to say keychain and keychain. I'm going to call it capital NetW207. Right? I got big fat fingers. I can't type. All right, and I'm going to give it the key ID number 1. And then I'm going to say the key string. And let's say we call it Cisco 1. Okay, now we created the key chain called NetW207. Then I'm going to go to this interface. That's where I'm exchanging my updates from, the serial 000. I'm going to go to interface serial 000, and I'm going to say IP authentication. Oops. IP, not IP summary, authentication, AUTH, authentication. And I want the mode for EIGRP number 10. I want to use message digest number 5. All right. Now it's going to bring it down because this guy doesn't have any authentication. So because you just enabled authentication using message digest number 5. And then I wanted to say authentication, and you're going to say I want the key dash chain for EIGRP number 10. Use the key use the key use the key chain called NetW207. All right. So now I got to repeat the same process for R2 and set that keychain on this serial 000 so they'll be all okay. So let me go in there. I've got all these different problems in here. Type exit. Let's create the chain. Keychain. Oops. Keychain is called netw207. And let's say it's a key 1. And let's say that the key string is Cisco 1. I'm going to go to the interface serial 000. See, we changed this hold down timer. It's 50 is no good. It's making it go crazy, going up and down like crazy, right? Between these two guys. So we'll fix that up. See, it expired already because the hold down timer is all screwed up. All right. So let me go to the serial 000 and say IP authentication. The mode for EIGRP number 10 is MD5. And then I'm going to say, I want you to use the keychain for EIGRP number 10. Schlitz. Sorry about that. IP authentication. IP authentication. Keychain for EIGRP number 10. I want it to be what? NetW 207. And bingo. Now I made adjacencies and we are all good. Now, how do you know that they made adjacencies? Let's do Control Z and do show IP route. And as long as you can see the network 150/80, that means they were able to exchange updates with each other, right? And this guy, we should be able to see show IP route. You should be able to see we're on R2. Yeah, I was just there. Let's go to R1. And R1 should be able to see, let me just do Control Z, show IP route. You should be able to see here is everything from R2, right? So they are exchanging, so the authentication works. All right, now let me go to R2 and type show IP protocols. And if I type show IP protocols, you see that you're running EIGRP number 10, right? And what else do you see in here? Here's what you're routing for. That you're transmitting all 5 networks right here. The passive interfaces are the 3 loopbacks like we did, correct? Here's the K values if you want to change how they calculate the best route to the destination, correct? All right, this is pretty much it. So we can go in there and type in, well, if you go back right in here, back into our, what we were doing was troubleshooting. So let's assume that these are problems that we're having with the hold down timer is always the default hold down timer, right? It's being set at 120 and I changed that to 50. So it's going crazy. It's just, there's almost no time whatsoever. If you go to here, show IP EIGRP interface serial 001. Show IP interfaces. Forget about EIGRP. And show IP interfaces serial interfaces show IP EIGRP number 10 interfaces, and I want, oh God, show IP interfaces for number 10. Well, actually what I want to do is let's use show IP interface, and what else can we do? Show IP serial triple or 001, right? And that tells me here's the IP address, the MTU max, and it really doesn't tell us anything else like that. But let's see in here. We'll get back to that when we are troubleshooting. So let's see which commands. We can use the neighbors, the show IP routes to tell us if you want to troubleshoot, if you see if your neighbors are correct or not, right? Show IP interfaces brief. That just tells us briefly who are the interfaces that are up and running, right? Make sure that both are up. Show IP protocols. Uh, that should tell us if we are verifying that you are running EIGRP or not. All right, show IP EIGRP interfaces. It gives you all the interfaces that are participating in EIGRP, if they are working correctly. The passive IP networks, right? Show IP protocols, we did that. And this is, we set the IP interfaces. You do not want to set the IP interfaces on the serial ports, of course. All right, so and this is how you can set up a network. I mean, if your network is missing, you go in there and you advertise it. AutoSummarization. All right, so they really don't tell us they didn't give us a command to actually check out the interface, this interface serial 0. So what I'm going to do is I'm going to do show IP interface I want show IP show IP EIGRP. Okay, EIGRP. And I don't want neighbors, I want interfaces. No, that doesn't work. I don't want that. I don't want neighbors either. I don't want traffic. So IP interface, and let me see what else choices do I have. Show IP protocols. No, that doesn't help. Show IP interface. Let's try interface. And show IP interface. Show IP interface. Oops. 0 shut down. Why did I shut that down? See? Oh, it's not shut down. All right. You know what? Let's just go. The hello address is not set on the serial 000. If you type show IP, one more thing. Let's do show IP protocols. Okay, and redistribute static. We got it already, and it doesn't show any hellos. All right, you know what? Config T, go to the serial. I'm on R2, right? Go to the serial 001, right? Interface S001, and we are going to do, oh God, no IP hello interval for EIGRP number 10 to be 50. Just take it out. Okay. And go to the other router and do EN config T. Go to the interface serial 000 and say no IP, hello. See, it's good. No IP, hello interval for EIGRP number 1050. So that should take it out, and that should solve all the issues. So if I type show run, and it's not in there anymore, it's taken out. So we're back to the 60 and everybody with the hold down. We were not able to create the hold down timer, so that created an issue. We decreased the hello interval and the hello down and the other timer we were not able to do that. So we were start the hold down timer. We left it the same 120. So it's supposed to be 3 times as much. So that's why we were having issues, and we didn't give us a command to actually do that. Anyway, so this is it for chapter 8. So please save this, and this is the only thing that you are going to attach for chapter 8 as your homework. All right? So next week we'll talk about chapter 9, and until then, keep studying. We're almost there. We're almost towards the end. And until chapter 9, God bless.